Hi friends, good morning to everyone. We are discussing the functions in C++. In the last session, we have discussed what is function overloading and when to overload several functions at the same time. What are the rules for function overloading? When function overloading is not possible, right? These are the things that we have discussed in the last session. Can anyone tell me, right, in short, right, what is function overloading?
Sir, it has same function name but different number of parameters and different types of parameters.
Very good. We can define several functions. So to have function overloading, how many functions are required in minimum?
Two, sir.
At least two functions are required, right? So minimum two functions are required. Maximum, right, you can have any number of functions. So when the functions are differing in the parameter list, we can say the functions are said to be overloaded. So to overload several functions, the first restriction is the several functions, right, must have the same name. Function name, right, must be identical one. Second one, they can differ in their parameter list. That means the functions may differ in the parameter list. Can you tell me in what way the parameters are going to be differing to achieve the concept of function overloading? Yes, make it fast. In what way the parameters are going to be changed so that function overloading is achieved? Yes, tell me. We have discussed the rules, right, in the last session. Number of functions. You please unmute yourself and speak with me. How function parameters help to achieve function overloading? What are the restrictions? Anyone? Shanmuga Reddy, Vishnu, Roshini,
And number of parameters and type of parameters also.
functions. Yes, good. Functions should differ in the number of parameters and type of parameters. At the same time, they can also differ in both number and type of parameters. So when they differ in both number and type of parameters, we can say the functions are said to be overloaded. And we have seen the important rule, right? When is function overloading not possible? So having two functions with the same function name, same parameter list, but when they differ only in their data type, that is return type, we have distinguished that return type alone is not the necessary condition for function overloading. So void FGH and char FGH, right, in the last session we have discussed. Even though, right, the function name is same, function parameters are same, but they are differing only in their return types. So return type alone is insufficient to determine the function overloading. and we have explored the rules of function overloading. Can anyone tell me the rules of function overloading? What is the first rule?
Same function name, sir.
Okay, assuming that the functions are going to be overloaded. Now consider the calling statement and the function to be called. So with respect to the actual parameters and formal parameters, we have defined the rules of function overloading, right? Can you tell me the rules of function overloading? What is the first rule? Compiler checks if there is an exact match between the actual and formal parameters. You should have checked the video and the programs that I have posted in the last session, right? So we have clearly explained the rules of function overloading along with one example. So let us revise once again. The first rule is compiler is going to check for the exact match between the actual and the formal parameters. In case if there is an exact match between actual and formal parameters, the corresponding overloaded version is called. This is rule number 1. Second rule, if there is a mismatch between actual and formal parameters, compiler tries to apply for automatic type promotions. In case if automatic type promotions are applicable, then the corresponding overloaded version is called. This is the second rule. Next rule, in case if the automatic type promotion results in a failure one, then we can conclude that compiler results the error message. So the corresponding function will not be going to be called. Instead, compiler reports error message. These are the rules of function overloading. Finally, we have discussed the term ambiguity. Ambiguity in function overloading. But it's an ambiguity, whenever the automatic type promotion rules are applied, there can be a multiple match between the actual parameters and formal parameters. In that situation, what will happen is ambiguity, the compiler, reaches the ambiguous state. That means since there can be multiple matches for the actual parameters, compiler will have a confusion to execute the multiple function calls. So compiler will not execute the right function to be called. That stage simply it reports the error message. So in this session, we focus on what are the possible ambiguities, right, that are going to be raised in function overloading. Now to consider the code hash include iostream.h, then defining a main function int main, having the statement return 0, have some function declarations, suppose f of int, f of char, f of long, f of float, f of double. Now define these versions. First one f of int. Let us write the statement cout less than int version is called. Less than we are printing the value of int. So here parameter is, for example, int x. See out lesson, int is called x, printing the value of x. Then en dx, closing the function definition. So as usual, right, we are defined the function, right, f of int x. One integer parameter is passed as the actual parameter, then the version is defined here. Likewise, defining the character version. So I use copy paste, shift insert second version. Let it be a character one. Character x cout. The character version is called. Assuming the value of character x is printed. Then shift insert. We are redefining the long version. Long x cout. Long is called and the variable x is output. Then shift insert. We are calling a float version. Float x cout. Float is called. Then shift insert. Last one, say double version. Cout. Double is called. So having these versions, overloaded versions, clearly the function f is to be overloaded, even though these functions are having exactly one argument, but they are differing in the type of parameters. So the important rule for function overloading is, right, when the number of parameters is same, the functions should differ in the data types, type of parameters. Here integer version, here character version, here long version, here float version, here double version. So when we call the function, right, using the right parameter, the right version is going to be called. So we are checking, right, first the exact match between the actual and formal parameters. So let us have the function calls. Suppose f of all x, then f of 100, then f of 50. Can you tell me how to define the long integer constant in C++? How to define the long integer constant literal in C++ or even C language? 100, right? 100 comes in which constant? Integer constant or long integer constant?
Integer constant, sir.
Integer constant, very good. To make 100 as the long integer literal, that is long integer constant, what is the change to be made in 100? What character, right, should be affixed with 100? Can't you remember that? In C language, right, we have studied same concept. If you append, right, small l, what is this indication? What is the indication of small l? This is l, right? Not 501, 50l. Or you can use, right, capital L. Let me use, right, capital L for clarity. Small l is deleted. What is the difference between 50 and 50l? Yes, tell me. 50 is normally the integer constant. What about 50L? Small l or capital L, right? 50 small l, not 501, or 50 capital L. So if you write add append small l or capital L character, then this indicates long literal. Understand or not? Understand or not? Please interact with me. Having any queries? Are you able to understand or not?
No, sir. Understood, sir.
Okay. 50 means right normally the integer constant. Writing 50L or 50 capital L, this indicates a long integer one, long literal one. Then floating point one, for example, f of 12.56. How to define a floating point constant? 12.56 is normally a double constant one. To make this as a floating point one, for example, 3.14159. To make this as a floating point constant one, you need to append, right? Small f or capital F, 3.14159, capital F. This indicates this is a floating point literally. And to make right actually the double value, we can write, for example, f of 1.2345. So by default, right, this is a double quantity, double precision value. All floating point numbers are by default double precision quantities. Double precision, right, accuracy is increased. Single precision, right, floating point one, explicitly the floating point number should be appended a character small f or capital F. Now have a look into this example. At this example, right, let me save the file. CEX16. Good. File name is CEX16.cpp. Now we are having the function declarations int char long float double. So to illustrate that, right, we have defined, right, the function call statements, character 1, integer 1, long 1, float 1, double 1. Now let us check the code. I have compiled the code, right? Program has been successfully compiled. Now I am pressing Ctrl F9, running the code. Have a look into, right, the verification of our rule number 1. How compiler checks the exact match between the actual and the formal parameters. In the first version f of x, right, what happens? The value of x as a character 1 is passed to the character version here. So the character version is called and the value of x is printed. X is x, right? Since the character x receives, right, the actual parameter x, so the value x is printed. Second one, f of 100, actual parameter is of integer type, hence integer version is called. So the result is 100. 50L, right? What happens? The long version, because 50 means, right, integer version will be called 50L, that is a long literal constant. So passing the long literal constant, the long version, right, overloaded long version, this one will be called, hence we can have the result long, long is called. Then 3.14159 F, this F is the indication of floating point literal. So floating point version, this version is called. Then F of 1.2345, right? Function name is F. The actual parameter results in a double quantity. So double version is called. So first basically understand how to define the strong, right, literal types, right, literal values, and how the literals, right, are actual parameters are checked for the exact match between the overloaded function calls. So in this case, calling rate f of 1.2345, here by default, this is a double quantity, double version is called. Have a look into the last line, 1.2345, double is called. But previously, since we have appended a character f, the floating point version is called. Understand? Understand the rule number 1. When the compiler checks exact match between the actual and formal parameters, the right overloaded version is going to be called. This is rule number 1. Having any queries in this rule? Have any queries?
No, sir.
Okay. Now we are going to write check how automatic type promotions are going to be carried out. Now have a look into this example. First right we are starting from the character one. So I am commenting right these function calls. Commenting these function calls. First we are checking the character version. In this case, I am commenting these methods. Long float double, right? These are commented out. Here also comment long float double. Having only two versions. One is f of int and another one is f of char. So int version is defined here, character version is defined here. But character write character. In this case, what happens? If you run the code, control F9, char. Since there is an exact match between char and char, the character version is called. So this version is called rule number 1. Now write commenting the char version. Here also I am commenting the char version. File save. I am running control F9. Have a look into this outcome. Actual function call is f of x, a character 1. Actually, the function called is f of int x. How this is possible? Integer and character are compatible data types in C and C++ languages. So, if the actual parameter is a character 1, in case when there is no match, no exact match between the character and the character is a type promoter to integer 1. Understand or not? So the character x, this is type promoter to integer 1 and the corresponding integer version is called. Clear?
Yes, sir.
Okay. Now I am closing this and removing this integer version and have a look into this long version alone. Okay. Only long version is here. Understand clearly the exact rules of function overloading. We have only the long version. Here, long version is defined. Remaining versions are commented out. Since no exact match is found, character is type promoter to long one. So long version is called. Now, I am commenting this long version. Have only a floating point version. Here also comment long and have a floating point version. Control F9. Float version is called. The value is 120. So character is type promoter to floating point 1 and the exact match is found in this case. So removing this float and have the double version. Here have a double comment on a floating point version. Control F9. Double version is called. So the first important rule is here. Let me write the rules. Please take the rules. As far as character is concerned, it checks for exact match between char and char. If there is an exact match char and char, right? What happens? The exact match. Char version is called. Char is called. In case only int version is available, or float version, or long version, or double version. In this case, when we have only integer 1 or floating point 1 or long version or double 1, then only write one version is called. Only one version is called. So in this case, right, what happened actually, automatic type promotion rules are applied. Automatic type promotion rules are applied. This is the second rule. Exact match right version is called. In case if the compiler succeeds applying automatic type promotion rules, the concerned version, right, having only one, right, character to integer or character to float or character to long, character to double, whatever you have, that right version is called, right? This is the second rule. Next, have a look into this combination. I have the combinations of int and long. Understand carefully. Only we have the combinations of int and long. So as we have done earlier, right? Ignore these, right, statements as commented out. Character is called, right? Having only the versions int and long. Int is here, long is here. Commenting right to the double version. I save the file save, then F9, no compilation errors. Actual parameter is character 1. Actual function definitions are integer and long 1. Character is first type promoter to integer 1. This is a rule because character and integer are compatible data types. In this case, pressing Ctrl F9, int version is called. There is no ambiguity between char to int or char to long because character and integer are compatible data types. Character is first converted to integer 1, then compiler checks immediately if there is an integer version. In case the int version will be called, right? So you can have the combinations of, right, whatever is int long or int float. I show you, right, the combinations of int and float. Here int and float, commenting float, save the file, pressing Ctrl F9, int version is called. So have a look into, right, this logic. So what is the logic? Char, right? This is the actual parameter in a function call, but in the function definition, if you have int comma root, this is one possibility, or int comma double, another possibility, int comma double, then int comma long, int float, int double, int long. In this case, what happens? Int version is called. Int version is called. What is the reason? Why is int version called? Why not float, double or long versions are called? What is the reason? What is the reason? I have said many times the reason. Because integer and character is first type promoter to integer version. That means character and integer are compatible types. So even right, you can have the different versions. Not only right int and long. We have int long, int float, int double. Here also excluding char, int long, int float, int double. In these combinations, since character is type promoter to integer one, we can conclude only the integer version is called. In this case, there is no ambiguity between char to int, char to long, char to float, char to double, or no ambiguity between int, long, float, and double data types, because char is first type promoter to integer one. In this case, if there is an integer version will be called first without any compile time error. Understand the rules? Understand the rules? Having any queries? Please interact with me. Having any queries?
No, sir.
Ganga, Mitra. Okay. Now have a look into the function call statement as a character one. I am removing the integer version because we have tested first character is type promoter to integer one. This is very important rule. Please attend the sessions right carefully. Now the integer version is commented out, right? Having the versions long and float only. Long and float. Here also integer version is commented out. Having long and float. So commenting the double version. Here also double is commented out. Actual parameter is a character one. See how character is type promoted in automatic type promotion rules. First I press F9. It shows right one error. Can you predict the error? Of course, no syntax error, right, in our code. So the logical error, right, is going to be assigned. Pressing right OK, you can find the ambiguity between long and float. Have you seen right? Are you seeing right this line before the taskbar? Ambiguity between f of long and f of float in function main. So what this error signifies? The actual parameter is a character type. Character is right type promoted further to integer one. No integer version is there in your code. So integer is right further type promoted to both long and float one, because long float double, right? These are the numeric types. Integer is further, int data type is further type promoter to long float and double. So we have the ambiguity between long and float in this case. In case if we have instead of long float, assuming the combinations long and double, here assume the combinations. Let us comment on float and having the combinations long and double. File has been saved. Pressing F9, pressing, we can see the error message. Ambiguity between long and double, because the character is further type promoter to integer, integer is further type promoter to long as well as double. If you have only one version, no problem. So having the compatible versions, long and double, right? Or long and float, or float and double, are having, right, all these possibilities, long, float, double. In this situation, compiler raises the ambiguity error, right? So this is the next rule. When there is a mismatch between actual and formal parameters, and when the compiler tries to apply the automatic type promotion rules, in this case, in case if we have the compatible values type data right is type promoter, and then when we have multiple match between, right, so I write here, please take it, multiple multiple match between actual and formal parameters, actual and formal parameters. That means char, right? Char is further type promoter to float comma long, or float comma double, or long comma double, or even having the options float, long, double. Anyhow, when the char is type promoter to integer first, then integer is char is first type promoter to integer one. Then integer is further a type promoter to float, double, long. At the same time, that is a problem. That's what, right, whenever we have the combinations of float long, float double, long double, or even we have the multiple, right, match as float long and double types. In this case, compiler reports ambiguity error message, ambiguity error, because compiler will not have the right chance to execute any one person, since there is a multiple match between actual and formal parameters. So in this situation, right, char is type promoter to float long double, so we have the ambiguity error message. So when the automatic type promotion, right, succeeds, further there may be a chance to occur the ambiguity error. We have to understand this rule first. So these are the rules for, right, character data types. How character is type promoter to integer one, and checking the exact match between, right, char int, char float, char double, char long, right? And having the multiple match between actual and formal parameters to rise in the ambiguity error. Hope you understand. Second one, can consider the integer data type. With respect to integer data type, as we discussed earlier, when we have only right the integer version will be called. In case when we have right integer as well as the float, long, double values, in that case, because integer is type promoter to float, double, long. Just now we have seen from character 1 implicitly character is type promoter to integer 1, further integer is type promoter to float, long and double. So have a function called as integer 1. I am commenting character version. Only the integer function is called f of 100. Here have the versions comment on right long. Have a versions only float and double. Here also have the corresponding function prototype float and double. What happens? Integer actual parameter. Formal parameters are no integer 1. Instead, right, we have the combinations of float and double. F2, F9, one error. This will not compile because there is an ambiguity between float and double in function meaning. So what is the ambiguity? The integer version, right? This is type converted to float, double, long. So when you have these combinations, what are the combinations? Float, double. You can also check these combinations. Float, long, then double, long, or even right you can have all these three right versions as we defined right previously for char type. So how to have float, long, double. So having all these things, in this case what happens? Ambiguity error is the result. Ambiguity error, ambiguity, right? Multiple match between the actual and the formal parameters. Understand the logic? Say yes or no.
Sir, what about into character?
What about
Int to
into
character,
to
sir.
character? Into to character, right? Will not be type converted, right? Character is because in C language itself, you have learned that. Please understand, character occupies 1 byte, integer occupies 2 bytes. Higher range, right, cannot be held directly in the least data type or lower data type. So assuming, right, here int version is available in the function call and have only the character version, please check it, right? Into to char type conversion is not possible because integer is higher data type, character is the least data type. This results in compile time error.
Okay, sir.
Understand?
Yes, sir.
Next rule. Considering the long data type, let us have the actual parameter as a long one. So I am removing right this statement, right? Let me just comment out. Don't confuse. Actual parameter is right. We are coming to the long version. Long version here, as we asked, right? Long is a higher version, right? That cannot be converted to the character one. So assuming right no long, long to long, and having only these versions, a float and double versions. In this case, let us check right what will happen. Long, a float, double. Here, a float and a double are different. particular. Here a float and double are defined. F2, F9. This will not compile. Pressing. What happens? Ambiguity between a float and double in function name. So here long is there. Long is the integer quantity. Further type promoted to, right? This means here I write the words type promoted to float double long. Likewise, long is type promoted to what one? Float and double. So having float and double combinations. Long is the actual parameter. Float and double combinations. In this case, ambiguity error. In case, right, you have alone, right, either float or double. I show it. First, I comment on the double one. Here, double is commented on. I'll say F9, no problem. Control F9. Float is called 50. 50L, even though long integer 1. Since long is type promoted to float 1, only float version is there, so float version is called. Likewise, have only a double version. Here also change. I am changing this into a double version. Control F9. I can see the double version is called. So understand clearly, long is a data type that is further type promoted to a float or double types. When you have the combinations, right, float double, this results in the ambiguity error because long cannot be, right, type promoted at the same time to float or double one. This results in the ambiguity error. Understand the rules of function overloading? Having any queries in this? Have any queries? I'm waiting for your queries. Jayaraju, Jayaraju, are you there? So understand the rules clearly. We are summarizing the rules of function overloading as we have formulated in the previous session. Now we have completely verified the rules. The rules are to overload several functions. Several functions should have the same name first. The functions should differ in number of parameters or in type of parameters. When the functions have the same number of parameters, they should differ in their data types. That means the type of parameters. Or the overloaded functions can differ both in number and type of parameters. These are the necessary and sufficient condition for making, right, several functions as overloaded one. Second, right, how will be the flow of execution of overloaded functions from the actual parameter to the corresponding formal parameter. First, the compiler tries to check if there is an exact match between actual and formal parameters. When there is an exact match between actual and formal parameters, only the one version, right version is going to be called. In case if there is no exact match between the actual and the formal parameters, compiler tries to apply the automatic type promotion rules. So remember, as we discussed in this session, how automatic type promotion rules are applied and what are the possible chances. Normally, right, character and integer are compatible data types. So if the actual parameter is a character 1, character is simply right first type promoter to integer 1. Hence, right, whenever we have the functions in the combinations of int float, int double, int long, and since the character is first type promoter to the integer 1, only the integer version is called, irrespective of having other versions as float, double, long. That will not be a problematic situation. But when integer type is missing and having right several competing types or matching types corresponding to char as float, long, double, having the combinations, right, float, double, float, long, then double, long, are having right all these combinations, float, long, and double. This results in the ambiguity error because compiler right will not understand what is the right function to be called. It cannot determine right which is the right version to be called. That stage, the ambiguous, right, that is not a clear one, right, unclear one. Ambiguity error is raised. This is a rule corresponding to the char data type. In reverse, right, into to char, right, this is not accepted because integer is a higher data type and character is the least data type. And coming to right the integer data type, into to int, no problem. Assuming that no int version is defined right in the overloaded version, because integer is a type promoter to a float, long, and double types. Having these combinations, float, double, float, long, double, long, are having right all the three versions, float, long, and double. In this stage, there is a match between right multiple match between actual parameter and several right function definitions. In this case, right, the compiler right results in the ambiguity error because having right multiple match between actual parameter and function definitions, only one function is going to be called when you call a function. Multiple functions cannot be invoked right simply from a simple right function call. So compiler clearly reports the right error as ambiguity error in this situation. Then coming to the long data type, since long is right type promoter to right float or double, having the combinations right float and double, long parameter right cannot be matched to call both a float and double versions. This stage, the compiler reports the error message. The error message is ambiguity error message. These are the rules of function overloading. You try to write solve these problems. Now I write the problems, exercises. First one, using function overloading, find the area of two-dimensional objects. You can assume, right, some of the two-dimensional objects, say a circle, right, square, rectangle, right, a triangle, like that, right? You try to assume some are two-dimensional objects. You need to find their area, right? Area of circle, area of square, area of rectangle, area of triangle. Only thing is you need to apply the overloading concept. What is the overloading to be applied here? Function overloading. So apply the proper function overloading so that you can call the versions of a different functions, right? So functions, right, can be defined with respect to some parameters. Because of overloading, the functions may differ in the number of parameters or type of parameters, or they can differ both in number and type of parameters. So you try to write a program, right, to overload the several functions to compute the volume of the relevant two-dimensional objects by deferring the parameter list in number of parameters and type of parameters, or we can write differ both in number and type of parameters. Second one, same way, right, find the volume of some three-dimensional objects, say a rectangular box, cylinder, a cone, right, we can use, right? So find the volume of some three-dimensional objects using function overloading. How to solve these problems? Define a main function, define the objects, right? For example, square, circle, something. Try to identify the number of parameters required to compute the area or to compute the corresponding volume based on the number of parameters, right? So try to change their data types, right? So when you have the same number of parameters are there for different objects, try to change, right, the parameters in terms of, right, integer, float, long, double, so that to pass the relevant values from the function call statement to the function definition based on the number of parameters, type of parameters, or both number and type of parameters. You can differentiate the overloading of several functions. Only one important thing is all of these functions must have the same name. So you can define a function, for example, find area or compute volume. So that function, right, should be the same. Only thing you can vary the number of parameters and the type of parameters, are both the number and the type of parameters can be changed. Based on that, right, give a reasonable output statements. For example, computing the area of circle, computing the area of square, finding the volume of a rectangular box, finding the volume of a cylinder, right? Volume of cone, like that. We can give the reasonable output messages. So try to solve these two exercises, right? In terms of a function overloading. Having any queries? If you have any queries, you can ask.
No, sir, no queries.
Good. Okay. So
No
I
queries,
posted the
sir.
videos right after some time. The program also, right, I posted in the GCR. Please go through the programs, right, and carefully verify the rules of function overloading. Try to write work with the program and solve these two exercises, right, and we will discuss in the next session. Thank you very much.
Thank you, sir.
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 Akshaya, have any queries? Akshaya, are you there? Have any queries? Akshaya, are you there? Having any queries?